Okay, so on these first two problems, we're asked to use the rational root theorem to go ahead and list all the possible rational roots and then find any actual rational roots. So we always do P over Q. So our P value is always our ending thing, and our Q value is always our first coefficient. So listing out all factors of P is plus and minus 1, plus and minus 13, and then our Q value is plus and minus 1. Now, we have to list all possible P divided by Q's, so plus or minus 1 divided by 1 is 1, and plus or minus 1 divided by, or 13 divided by 1 is 13. So these are the only possible rational zeros. So we've listed out all the possibilities. Now you'll take your calculator and find any actual rational zeros. So you'll take your calculator. I'm not going to spend time doing that. You should know how to do it by now. You'll graph it in your graphing calculator, and you'll see where it crosses the x-axis. So it's something like this. So it's crossing the x-axis. You do a left bound, make sure you're left of it, a right bound, make sure you're right of it, and then it will give you this value. If you do that, you get x is equal to 1, so our actual rational zero is 1. So we do that same thing with number 2. This is our Q, this is our P. Factors of P, plus or minus 1, plus or minus 7, and Q, plus or minus 1, plus or minus 2. So all possible P divided by Q's, plus or minus 1 over 1 is 1, plus or minus 1 over 2 is 1/2, and then 7 over 1 is 7, and then 7 over 2 is 7/2. Then you'll take your graphing calculator, you'll type it in. And you have one, if you type it into your calculator, so in your calculator it looks something like this. It's crossing the x-axis at some point. You'll do second trace, you'll find a 0, and you get 2.774. Now you need to check that. That's the actual 0. You need to check that with your possibilities and see which one that could possibly be. Well, we know for sure it's not 1/2. Obviously, 2.7 is not 1/2. It's obviously not 1. It's obviously not 7. But what's 7/2? So this is where I take my calculator. You do 7 divided by 2. So 7 divided by 2 is 3.5, which is also not that. So our answer would be no actual rational zeros. So this would actually be our final answer for this one. No actual rational zeros. We listed out the possibilities, but that was not any of our possibilities. Now that is still a 0, it's just irrational. So we do the same thing here. Our P value, our Q value is 1, our P value is 2. So plus or minus 1, plus or minus 2, those are factors of 2. Q, factors of 1 are plus and minus 1. P divided by Q's, all the possibles. 1 divided by 1 is 1. 2 divided by 1 is 2. So these are the only possible rational zeros. So if it's crossing the x-axis and it's rational, then it's going to be at 1, -1, 2, -2. So we type it into our calculator on number 3, and once again, it's crossing. Now make sure your window is big enough. So it's crossing somewhere over here. So I do second trace, I find the 0, and you get the actual rational zero is 8.03. Now that's obviously not 1, it's obviously not 2, so this one's also no rational zeros. Once again, that is a 0, but it's not rational, because if it was, it would have been in this group. So no rational roots, no rational roots. So that would be our final answer for that one. So number 4, this is our Q, this is our P. So P is plus or minus 1, plus or minus 3. Q is plus or minus 1, make sure you list them all, plus or minus 2, plus or minus 4. Those are all factors of 4. So then all possible P divided by Q's, this one's a little bit bigger. 1 over 1 is 1, 1 over 2 is 1/2, 1 over 4 is 1/4. So I just took care of 1. 3 divided by 1 is 3. 3 divided by 2 is 3/2, so plus or minus 3/2. And then 3 divided by 4 is 3/4, so plus or minus 3/4. Then I'm going to take my calculator, go ahead and graph it. And in your graphing calculator, you graph it, it's crossing somewhere over here. You'll do second trace, and it crosses actually at x is equal to -3. So our actual rational zero is -3. So you do the same thing for number 5. This is our q, this is our p divided by q. They're possible values of p, so we're getting a little in head. Plus or minus 1, plus or minus 2, plus or minus 4 are q's, plus or minus 1. So all possible p over q's are plus or minus 1, plus or minus 2, plus or minus 4. So then you graph it in your graphing calculator, and on number 5, it's crossing it in many places. So we have our graphing calculator. It's crossing like, looks like this. So it's crossing in 4 places. You've got to trace and do the zeros on all of those. So when you're doing left bound for this, you've got to be over here. Right bound, you've got to be over here. For this 0, your left bound is going to be here, your right bound is going to be here. Once again, for this 0, your left bound's here, your right bound's here. For this 0, your left bound is here, your right bound's here. You got to type it in correctly. So if you do that, you get x is equal to -1, you get x is equal to 1, x is equal to -2, and x is equal to 2. And it makes sense because that was in our possibilities, so we've done this correctly. Okay, same thing here. Now this one's huge. So this is our q, this is our p. Unfortunately, huge. Possibilities that multiply to be 81. 1, 3, 9 plus or minus 9, plus or minus 27. No, yeah, 2. I forgot 2. And plus or minus 27. And then factors of q, plus or minus 1, plus or minus 5. So our possibilities are huge in this one. We would list them all out. I'm not going to do that. And then we would use our graphing calculator, and it crosses the x-axis in 2 places. So it looks something like this. So it's crossing in 2 places. You'll do trace, and you get x is equal to 3 and x is equal to -3, which would have been in our possibilities had we had listed them, because we do 3 over 1, p divided by q is plus or minus 3. So those were our possibilities. So we've done this correctly. Okay, number 7, it says given a polynomial has these zeros, find any remaining zeros, then find a polynomial in standard form using the zeros. So we know that these are zeros, so they're x values. X is equal to -4, x is equal to 3 plus I. Now remember, the conjugate root theorem says if you have an imaginary root, then its conjugate is also a root. So this is an imaginary root, so its conjugate x minus I is also a root. So then you're going to bring those things over to find the polynomial. We need to get a set equal to 0. Add 4, add 4. So you have x plus 4 is equal to 0. And then you would subtract 3, subtract I, subtract 3, subtract I from both sides of the equation. X minus 3 minus I is equal to 0. And then I'm going to subtract 3 plus I, subtract 3 plus I. So I also have x minus 3 plus I is equal to 0. So we have x minus 3 plus I is equal to 0. And now you'll multiply those things together. Now make sure that when you are multiplying these things, you always multiply the conjugates together first, because a lot's going to cancel out and make your life easier. So I'm just going to multiply these 2 things together first. Very carefully though. X times x is x squared. X times -3 is -3x. X times I is ix. Changing colors so I don't miss anything. -3 times x is -3x. -3 times -3 is +9. -3 times I is -3i's. Changing colors again. -I times x is -ix. And then -I times -3 is +3i's. Be very careful with your signs, or things are not going to come out nicely. -I times +I is -I squared. Then from there, we're going to combine all like terms. Before I do anything else, combine all like terms. X squareds, no other x squareds. I cross it out as I go. -3x minus 3x is -6x's. +ix minus ix is gone. -3i plus 3i is gone. We have +9 minus I squared. And then remember, I squared is equal to -1. So we have +9 minus -1. So plus 9 minus negative 1. We have x squared minus 6x, and then because we're taking 9 and subtracting negative 1, we're technically adding 1, which is 10. So there's our polynomial, and we've got to multiply that to the polynomial we had up here, which was x plus 4. So we're multiplying that to x plus 4, and then from there we're going to distribute very carefully again. X times x squared is x cubed. X times negative 6, x is negative 6x squared. X times 10 is positive 10x. And then I have positive 4 times x squared is positive 4x squared. Positive 4 times negative 6x is negative 24x's. And then positive 4 times positive 10 is positive 40. Combine all like terms, and you will get x cubed minus 2x squared, and that was these two, and then minus 14x's, so I added up these two, and then plus 40. So this would be our final answer here. And we do the same thing for this one. We have x is equal to 5, x is equal to 2 minus I, so we know the conjugate x is equal to 2 plus I is also a root. Bring it over, so x minus 5, and then we'll have minus 2 plus I, minus 2 minus I from both sides, so I'm going to have x minus 2 plus I, and I'm going to have x minus 2 minus I, and then we're going to be multiplying all those things. And I always multiply the conjugates together first. So the same thing is going to happen here. X squared minus 2x minus ix minus 2x plus 4 minus plus 2i. Almost messed up. See how you have to be very careful. And then I'm going to change color so I really don't mess up. Positive I times x is plus ix. Positive I times negative 2 is negative 2i. And then I times negative I is minus I squared. Combine like terms. X squared, no other x squared. Negative 2x minus 2x is negative 4x. Negative ix, positive ix cancel out. 2i, negative 2i cancel out. We have plus 4 minus I squared. And we know I squared is equal to negative 1. So we're doing x squared minus 4x, and then we have plus 4, and then minus negative 1. So that'll be plus 1. So we'll have x squared minus 4x plus 5. So now notice when you multiply these two things together, these conjugates, you do happen to come out with a polynomial that doesn't have any i's. That should be true every time. So if you have some i's left over, something went wrong. So now we've got to multiply that to x minus 5. So then we'll distribute that through correctly. So x times x squared is x cubed. X times negative 4x is negative 4x squared. X times 5 is 5x. Negative 5 times x squared is negative 5x squared. Negative 5 times negative 4x is positive 20x's. And then negative 5 times positive 5 is negative 25. Oops. Negative 25, if I could fit that in there. And then we combine like terms. X cubes, no other x cubes. Negative 4x squared minus 5x squared is negative 9x squared. Positive 5x plus 20x is positive 25x's. And then we have our minus 25. And there would be our final answer for that one. Okay, continuing here. Number 10 says, factor the polynomial, then find all its zeros. So we factor different ways. This is not quadratic, so don't say a times c. But we have 4 terms. When we have 4 terms, we always try factoring by grouping. Group the first 2, group the second 2, including the sign. What's in common in this group? An x squared. Divide each thing by what you pulled out. So that leaves me with x plus 1. Now in this group, I have a positive 144 in common, so I pull it out. Divide each by 144. And left is x plus 1. Check your safe haven. If it's not the same, it either didn't factor by grouping, or you didn't pull out the greatest common factor, or you've done it wrong. So we pull out x plus 1. So it divided out because we pulled it out. And then left was x squared plus 144. Okay, we have factored this. Now the whole point of factoring is so we can set each piece equal to 0 and solve. X plus 1 is equal to 0. X squared plus 144 is equal to 0. Solve for x in each case. So x is equal to -1. Subtract 144. So x squared is equal to -144. Square root both sides. And we get x is equal to plus or minus 12i. So we have three answers, 1, 2, and 3, which should make sense since it was degree 3. Continuing, let's say here, it will just say factor. You have to decide I'm going to factor by grouping. There's 1, 2, 3, 4 terms. So we always try factoring by grouping. In this group, there's an x squared in common. Left was x minus 1. In this group, there is something in common, a 1. You always can pull out 1, so I'm pulling out positive 1. Left is x minus 1. Safe haven, pull it out. So then it divides out. Left was x squared plus 1. Now the whole point of factoring, set each of those equal to 0 and solve. So we add 1. So x is equal to 1, subtract 1. X squared is equal to -1, square root, both sides. And we get x is equal to plus and minus I. The square root of -1 is I, so we have these answers. Now keep in mind, these quadratics were quite easy to solve because they were quadratic and they were missing the x. But if it wasn't missing the middle term, then you would use the quadratic formula to solve. So make sure you can do that. Okay. Number 12, it says find all the zeros of the polynomial. So with this one, I'm going to practice it a certain way. The first thing I do is graph it in my graphing calculator. So if you graph it in your graphing calculator, it looks something like this. Then I do second trace and I find a 0. And I get x is equal to 2. So then I use synthetic division to divide it. So I have a 2 is a root. There's one of my answers, but I'm going to have 3. It's cubic. So I set up synthetic division here. So I have a 1, a -2, a 4, and a -8. And then I'm going to divide my polynomial down. Drop down that 1. 1 times 2 is 2. Add straight down 0 times 2 is 0. Add straight down is 4. 4 times 2 is 8. Add straight down is 0. That remainder has to be 0. Otherwise, this was not a root. So we know we've done this correctly. So this is our remainder. This is our constant. This is our x. This is our x squared. So we took this polynomial, we divided it down, and now we have it at x squared plus 4 is equal to 0. Now, we're not done. We can use this, though. We have a quadratic, and we know how to solve a quadratic. Now, once again, this one's pretty easy. To solve this quadratic, we don't need the quadratic formula. We could use it, but the easier way is just to get x squared all by itself, since we're missing that middle value. So we have x squared is equal to -4, square root both sides. So we get x is equal to plus and minus 2i's. So there's 3 answers. 1, 2, 3. There's our 3 answers, and that makes sense since it was degree 3. So number 13, once again, I always use my graphing calculator, and it says find all the zeros. So I find a whole number 0 if possible, and then I just use division to go through and find the rest. So if you graph this, it looks something like that. And it's crossing the x-axis at x is equal to -3. So I know that's one of my answers. I use synthetic division again, setting up my coefficients, a 1, a 5, a 7, and a 3. And then I draw my line, drop it down. 1 times -3 is -3. Add straight down is 2. -6, add straight down is 1. -3, add straight down is 0. Remember, your remainder better be 0, otherwise that wasn't a root. And it was a root. We know it was a root. Or you've done synthetic division wrong. So this is our remainder, this is our constant, this is our x, this is our x squared. So we have 1x squared plus 2x plus 1. And now we know how to solve a quadratic because we can solve using the quadratic formula or solving by factoring if possible. We are not missing our middle term, so I am going to choose to solve this by factoring. You could use the quadratic formula, but this one's quick factoring if it does factor, and it does, so it's easy to factor for me. So I'm doing what multiplies to be a times c and adds up to be b. So we know that's 1 times 1. So our factors are +1, +1, and we can quick factor since the a value is 1. So So this factors to be x plus 1 times x plus 1. Well, now that we've factored it, we can set our factors equal to 0 and solve. So I have x plus 1 is equal to 0, x plus 1 is equal to 0, solve for x. Subtract 1, subtract 1. So I get x is equal to negative 1, x is equal to negative 1. And I have three answers, 1, 2, and 3. Which makes sense because it was cubic, so I better have three answers. Number 14. I graphed this one on my graphing calculator. We're finding all the zeros. So on your graphing calculator, you have something that looks somewhat like this. I find the two zeros that I can, and I get x is equal to negative 3, x is equal to 3. So I'm going to use synthetic division to divide this down, but you got to be really careful when you do that because we're missing our x cubed. So technically we have 0x cubed, and we're missing our x value. So technically we have 0 x's. So when you do synthetic division, don't forget that. So you can use negative 3 or 3 first. I'm randomly choosing negative 3. So I set up my coefficients. 5, 0, negative 36, 0, and negative 81. If you forgot those zeros, you won't get it right. I'm going to spread this out a little bit prettier. You won't get it right if you forget the zeros. Drop that down. And we have 5 times negative 3, which is negative 15. Add straight down, negative 15. And then we have negative 15 times negative 3, which is 45. And then we add straight down, which is 9. 9 times negative 3 is negative 27. Add straight down is negative 27. Negative 27 times negative 3 is positive 81. Add straight down is 0. Remember, that better be 0, otherwise that wasn't a root, and we know it was. Or we've done synthetic division wrong. Or we forgot the zeros. So now these are the coefficients for my next, my polynomial. So I'm just going to go from here and use my next 0, which is 3. So I'm going to set up another thing, and I'm going to use these coefficients. So I have a 5, a negative 15, a 9, and a negative 27. We don't need to put the remainder of a 0. And then we do the same process. Drop straight down. So 5 times 3 is 15. Add straight down 0. 0 times 3 is 0. Add straight down is 9. 9 times 3 is 27. Add straight down 0. And this was 0. It better be. If this was a root, then we know for sure that our remainder is 0. So if this is if this is our remainder, then this is our constant, this is our x, this is our x squared. So we have 5x squared plus 9 is equal to 0. Now we could use the quadratic formula to keep solving, or we could just simply, because we're missing our middle value bx, we could just solve for x. Subtract 9, 5x squared equal to negative 9, divide both sides by 5. So we have x squared equal to negative 9 fifths. Square root both sides. Careful here, we've got to simplify these. I expect you to simplify these completely. So we have the square root of negative 9 on top, the square root of 5 on bottom. So I've got to keep simplifying this because we know that the square root of negative 9 is 3i, and we have plus or minus in front of this. And then we have the square root of 5 on bottom. But this is not considered simplified because we can't have radicals in the bottom. So we've got to rationalize the denominator. So I multiply the top and bottom by the square root of 5. So I have plus or minus 3i square roots of 5 all over the square root of, now remember, this is the square root of 25 because you multiply those together. The square root of 25 is 5, so all over 5. So we have x is equal to that. So there's two answers, 1, 2, and we have our answers in the most simplified form. And then we have 3, 4 answers. 4 answers, which makes sense because it was degree 4. Okay, so number 15, same thing. I always graph it in my graphing calculator. And we have some zeros once again. It looks like this. We have a 0 at x is equal to negative 3 and x is equal to 3. And those are just happen to be my favorite numbers today for some reason. So we do the same thing with number 15 as we did for 14. I don't think I'm going to spend more time doing that. It's the exact same as problem number 14, which you should now be able to do. Okay, number 16 is the easiest. It says, What polynomial has a graph that passes through these points? So we use the n plus 1 point principle. The n plus 1 point principle. So if we have 1, 2, 3, 4 points, you always use one less than that degree. So since there's 4 points, there's one less than that degree, so this is degree 3. So then you go into your graphing calculator, you do the stat key, and then over to into edit, and then in list 1, you type in your x values, so 0, -1 to -2. In list 2, you type in your y values, -1, -7, 17, and -27. And then you hit stat calculate, so you'll scroll over to calculate. So stat calculate, and then because it was degree 3, you'll do cubic regression line. And if you do that, you'll get 2x cubed minus 1x squared. So I'm just going to write minus x squared plus 3x minus 1. And that would be our final answer. This is the polynomial that had these points passing through it. Now, I'm going to do the same thing with 17, but I'm going to skip all of that. Just, there's 1, 2, 3, 4 points. So once again, our n plus 1 point principle says that we have n degrees. So if there's 4 points, then this would be degree 3. It's always one less. So if we had 3 points, we would do degree 2. And then from there, we just type it into our calculator, and if you do it correctly, you should get 1x cubed. So I'm just going to write x cubed minus 1x squared, so minus x squared plus 2x minus 3. Okay, number 20, it says, and 25 is actually the same exact problem. So it says, what is the degree of the polynomial that generates the data below? So remember, we can always test to see if we can figure out what degree it is by taking differences of our y values. So I draw my little thing in, I'm taking differences, which means I'm subtracting my y values, and you've always got to subtract the one that comes before the one above it. So you're going to be doing 7 minus 6. So you'll be doing 7 minus 6, and you get -9. 2 minus 7 is -5. 1 minus 2 is -1. 4 minus 1 is 3. Well, those are not the same when we took differences the first time. So let's try it again. So we're taking differences again. -5 minus -9 is +4. And -1 minus -5 is +4. And 3 minus -1 is +4. So we took differences 2 times. And so we know that we took differences twice. See, look, once, twice. So we know it's degree 2. So then once again, so this is degree 2. So it's quadratic. So then you'll do the same thing you just did with your points. You'll hit the stat key, so stat edit. You'll type in your x values into list 1. So this is what your list 1 should be. This is what your list 2 should be. Then you'll do stat calculate. And you'll do the, since it was degree 2, quadratic regression line. And if you do that, you will get the answer 2x squared minus 3x plus 2. So that would be our final answer. So if you take differences, same thing here, you should get 6, 0, 0, 6. They're not the same, so I took differences again. And I get -6, 0, 6, and they weren't the same, so I took differences again. And I get 6 and 6. So I took differences 1, 2, 3 times. So I took differences 3 times, so it must be cubic. And I do the same thing in list 1, I type in this. In list 2, I type in this. And then I get x cubed, so 1x cubed minus 1x, so minus x minus 9. So this will be our answer. Okay, so it says name the polynomial. We name it by its highest degree and number of terms. So this is degree 3, and it has 2 terms. And so this would be considered a cubic binomial. Because cubic, degree 3, binomial, because there's 2 terms. This is degree 5, and it has 1, 2, 3 terms. So because of the degree 5, it is quintic. You'll have to just have these names memorized. Quintic, remember 5 babies. Somebody that has 5 babies had quints, and there's 3 terms, so it's a trinomial. And we look at the highest degree, which is 4, and the number of terms, 1, 2, 3, 4 terms. So the highest degree is 4, that would be a quartic, 4 quarts in a gallon, quartic, and then there's 4 terms, so you have to say polynomial of 4 terms. So you'll have to refer back to that video of classifying polynomials, or hopefully you took a picture of this, because you need to know these names. Okay, so we're asked to simplify. Make sure that you don't multiply if you're not supposed to be multiplying. Now look, it's this polynomial, subtract this polynomial. So I like to write a -1. We're not multiplying this polynomial to this polynomial. We're subtracting, but we do need to distribute our -1 through. -1 times 24x squared is -24x squared. -1 times -2x is positive 2x's. -1 times positive 32 is -32. You don't need your parentheses anymore. You just distributed your -1 through. And then this, we don't need parentheses, x squared minus 25. From there, simply combine like terms in pieces, x squareds, no other x squareds. And then you have -24x's plus 2x's. Right? And we have, going back, realizing I made a little error somewhere. Okay, let's see. Realizing I made a little error. Hopefully you were like, kind of like, what is going on? So when we distributed that through, it should have been -24x squared. And I forgot to write x squared. I got going too fast. And then it was plus 2x and minus 32. Sorry about that. Okay, so combining like terms. X squared minus 24x squared is -23x squared. And then we have 2x, no other x's, so plus 2x. And then -25 minus 32 is -57. So this would be considered our final answer. Same thing here. We're taking this polynomial, subtract this polynomial. I like to write in my -1 and then distribute it through. So that'll be positive 4x cubed minus 5x and then minus 6. And we don't need those parentheses anymore. We'll drop the front thing down here and then combine like terms. So this is positive 4x cubed, so I write positive. Combine like terms starting with my highest degree here. And that's my x cubes, 2x cubes, plus 4x cubes is 6x cubes. 5x minus 5x is 0x's, so we don't write it, minus 6. Now these ones you are multiplying. Look, your things are right next to each other. That means they're being multiplied, so we will distribute. So we're going to have 2x to the 5th. When you multiply the same base, you add your exponents, and then plus 5x cubed. And then minus 7x squared. And then I have plus 4x cubes. And then plus 10x's. And then we have minus 14. Combine like terms. So starting with my x to the 5th, 2x to the 5th. No other x to the 5th. And then we have 5x cubes plus 4x cubes, which is positive 9x cubes. And then we have no other x squared, so minus 7x squared. And then we have plus 10x minus 14. So same thing here. We're multiplying. They're right next to each other, so we know we're multiplying. We have x to the 4th minus 4x cubed, and then plus 3x squared, and then minus 5x cubes. And then plus 20x squared. Don't make any sign errors on the test. That's a tragedy. Minus 15x. Combine like terms, starting with the highest degree. X to the 4th. No other x to the 4th. Negative 4x cubes minus 5x cubes is negative 9x cubes. And then plus 20x squared. Oh, wait. What happened? I made an error somewhere. I forgot to distribute x through to 3x. And so I have another 3x squared in here. So I have a 3x squared plus 20x squared is 23x squared. And then minus 15x. And we're done. So I just didn't make that third distribution for some odd reason. Oh, I did, and I wrote it. I see it. Okay, sorry. I did make the distribution, but the problem was I forgot to write squared right there. So I had 3x squared plus 20x squared is 23x squared, and then that's why I still had just minus 15x. So I got going a little bit fast, but this is truly the correct answer. So hopefully I didn't mess you up too bad on that. Okay, number 31, it says, what are the zeros of the function? Graph the function, find the relative max and mins. So I just graph it on my graphing calculator, and I find the zeros that way using second trace. So if you do that, you'll use your calculator. You'll x is equal to 0, x is equal to 4, x is equal to -1. And then also, you find the max and min. So our max is at -0.52, and our 4.5, and our minimum is at 2.5 and -52.5. So hopefully, I mean, if you graph it on your graphing calculator, it looks like this. And then you found your zeros, right? There's a 0, 0, and a 0. And then your maximum was here and your minimum's here. So you'll do second trace and you'll find all those using your calculator. You could find all of these using the calculator. So same thing with this next one. You can find your zeros using your calculator. And then I'm just going to write down the max and min. Now these ones, your x values are decimals. We get x is equal to 0, and then I have 2 more zeros, which I actually didn't calculate. So our min is at -0.4, comma, -10.8. And our max, that was our min, our max is at 0.59 and 3.48. So hopefully you're able to use your calculator and do that. This next one, they're already linear, so I'm just going to set each of those equal to 0. So I get x is equal to 5, x is equal to -3, and x is equal to 0. So those are my zeros. And then my max on this one, if you typed it in correctly, which you should practice, not just write it down, because I have it here, 14.8, because it really just takes practice. And if you type it in, you can know you're typing it in right, because you can check your answers with mine. So that's how you do these. Okay, number 34, it just says find all the zeros, the real or imaginary zeros. So we do this the exact same way we did on the problems. On problems 12 through 15, or possible if you do have 4 terms, you can try factoring by grouping. Otherwise, you'll do them just like problems 12 through 15, where you graph it in your graphing calculator, find whole number zeros, then use synthetic division. So you could do that one this way. I'm just going to say I like to factor if possible. There's 4 terms, so I factor by grouping. So I'm pulling out x squared. Left is x plus 1. I'm pulling out 1, so left is x plus 1. Then I pull out x plus 1, and left is x squared plus 1. Now I've set each of those equal to 0. And solve. So I get x is equal to -1, x is equal to plus or minus I, and I skipped steps, but that's very similar to another problem we've done, almost identical. It is identical, actually. So if you need help on that one, go back a little bit ago when we were solving by factoring by grouping, because this is actually the same problem, but you didn't realize it. Number 35, I'm going to do it once again, if I can factor by solve. So it says find all the real or imaginary solutions. So you could graph it in your graphing calculator, find the whole number roots, do synthetic division to get it smaller, to be quadratic, and then use the quadratic formula or whatever. But I actually like the idea of more factoring by grouping because there's 4 terms. If there was only 3 terms, you could not do this. So I factor out an x squared, left is x plus 3, pull out +4, left is x plus 3, and then I factor out x plus 3, and left is x squared plus 4, and then I set each of those equal to 0, so I get x is equal to -3, set that equal to 0, I would subtract 4, so we'd have x squared is equal to -4, square root it, we'd get 2i plus and minus 2i, so x is equal to plus and minus 2i. So like I said, if that was too quick, I already did an example of these two. It was technically problem number 10 and 11 are the exact same, it's just asking it in a different way. So you could have graphed it, found the whole number roots. So let's say you wanted to do it that way. You'd graph this in your graphing calculator and you'd have something that looked like this. you'd find the whole number 0, which would have been x is equal, oops, it would have been over here, I'm so sorry. It would have been over here, and we would have got x is equal to -3. Then we would have set up our synthetic division, and so we would have had a 1, a 3, a 4, and a 12. And then we would have gone through our process of synthetic division. We would have had a quadratic, which was x squared plus 4. And then we would have solved that way. So there's many different ways. It's just which way do you prefer? Okay, number 37, it says divide this by this. So you can either use long division or synthetic division. Remember, if you use long division, that's great. I always choose synthetic division because I think it's way quicker and easier. So I actually went through and just did synthetic division. Now with synthetic division, you need the root. So if this is the factor, then we could find the root by saying, okay, if that's the root, then we can set it equal to 0, subtract 1. So 2x is equal to -1, divide by 2. So x is equal to -1/2. So now we can use that root to divide. So we're going to use that root to do synthetic division. That's one way, or you could do long division. If you want to remember how to do long division, then you should watch the video on long division, because I always choose synthetic division. Then we set up our coefficients. So we have a 2, a 9, a 14, and a 5, and I'm not missing anything, so I didn't have to put in my zeros. Drop that down. That's a 2. 2 times -1/2 is -1. Add straight down is 8. 8 times -1/2 is -4. Add straight down is 10. 10 times -1/2 is -5. Add straight down is 0. Now remember, your remainder better come out to be 0. If this was a factor, if this was a root, and this was a factor, then this remainder will be 0. And it was a root, right? We solved for it by setting it equal to 0 and solving. Okay, so if this is our remainder, then this is our x, this is our x squared, this is our x cubed. So our final answer is 2x cubed plus 8x squared plus 10. That is the polynomial once you've divided 2x plus 1. So in this one, you're not solving the roots, you're finding the polynomial once you divide. So I divided using synthetic division, using the root, -1/2, and there's the polynomial. Number 38, it says divide x cubed minus x squared minus 2x by x plus 1. So once again, I choose synthetic division, so I'm going to say x plus 1 is equal to 0 minus 1. So I found a root, it's -1. I'm going to use that to do synthetic division. You could do long division, set up your coefficients. So we have 1, -1, -2, and the constant 0. And we drop. 1 times -1 is -1. Add straight down is -2. -2 times -1 is +2. Add straight down 0. 0 times -1 is 0. Add straight down is 0. So you have to be really careful with this one, because if you forgot that we were missing that constant and forgot your 0, you would have not come out quite correctly here. So if this is our remainder, then this is our x. If that's our x, that's our x squared. If that's our x squared, then oh, whoa, what did I do here? There we go. If that's our remainder, then that's our constant. I apologize. If that's our constant, that's our x. If that's our x, that's our x squared. So we have 1x squared, which is just x squared, minus 2x, and then plus 0, so I'm not going to write it with a remainder of 0. So that is the polynomial when you divide by this. So this would be our answer. You could have done long division, but I just choose synthetic division because it's quicker. So that's our answer. So understand. Now remember, since we only did division once, we went from degree 3 down to degree 2. So if you would have forgot this 0, you wouldn't have come out on top with degree 2. So you would have known something was off a little bit. Because if you're only dividing once, you better only come out 1 degree lower. So just make sure that you look, and if there's any missing things, you fill in your zeros, like in your synthetic division. So I'm going to do this one. Same thing though, right? It says divide this polynomial by this polynomial. It's just written a little bit differently. So I like synthetic division, so I know that I have x plus 5 is equal to 0, so I subtract 5. So x is equal to negative 5. That's what I'm using for my synthetic division. So I have negative 5, and I set up my coefficients 4, 21, negative 1, and negative 24. And I wasn't missing anything. We went from degree 3, degree 2, degree 1, and then degree 0. So we have this correctly. So we set up our little thing, drop that down. 4 times negative 5 is negative 20, add straight down to 1. 1 times negative 5 is negative 5, add straight down is negative 6. And negative 6 times 5, positive 30, add straight down is 6. So with this one, we do have a remainder here. Our remainder is 6, but we're just dividing these polynomials, so they never said that for sure this was a perfect factor. It just wants to know you can divide. So if this is our remainder, then this is our constant, and then this is our x, this is our x squared. So when we divided it, we got 4x squared plus 1x minus 6 with a remainder of 6. That is our answer here. Okay, so number 40 says, use synthetic division and the remainder theorem to evaluate p of negative 4 for p of x is equal to this. So you just can test to see if these two things come out evenly. So we're just doing two things. We're going to do synthetic division using negative 4, and we're also going to plug in negative 4, because the remainder theorem says if you plug in negative 4 into your polynomial, you'll get the same thing that you will as your remainder when you do synthetic division. So I set up negative 4 in my box here. 1, negative 3, negative 28, positive 5, and 20. And then I draw my line, drop this down. I'll go through this, and that's negative 4. Add straight down to negative 7. Multiply that up, you get 28. You get 0 when you add straight down. 0 times that, negative 4 is 0. Add straight down is 5. 5 times negative 4 is negative 20. And you add straight down, you get 0. So our remainder was 0. So now that could be true. Whatever your remainder is, better be the same as when you plug that value in. So p of negative 4 is equal to negative 4 to the 5th minus 3 times negative 4 to the 4th minus 28 times negative 4 to the 3rd plus 5 times negative 4 plus 20. If you type that whole thing into your calculator, you get it's equal to 0. So really with this one, you're just verifying that you've done this correctly. So we're evaluating this. This is our remainder. Our remainder happened to be 0 in this one. But in our next one, let's go through it. So we're going to do this using synthetic division. So you have 6, negative 1, 4, and 3. Draw your line, drop straight down, 6. And then you have 18, so 17. You have 51. And you have 55. And then 165, add straight down to 168. So that's our remainder. Now remember, if you plug in that value, p of 3, you better get that same thing. So 6 times 3 to the 3rd minus 3 squared plus 4 times 3, and then plus 3. If you calculate that in your calculator, you get 168. So you know that they were the same, so we're just showing that they're truly the same. Our remainder really does come out as that value when you plug it in. Okay, number 42, we're almost done here. We're going to go ahead and simplify. So remember that we're simplifying these rationals, so we're simplifying these fractions. The first thing we do is factor the top, factor the bottom. So in the top, the only thing in common is a c, so then left is 26c squared plus 91. Then I have on bottom, nothing is in common. So we have 2 times c squared plus 7. Now I looked at this piece and said, okay, did anything multiply to be a times c and add up to be b? And there wasn't anything. So it didn't factor any further, and then I did the same thing down here. What multiplies to be 14, a times c, and adds up to be b? Well, nothing. So this really doesn't factor any further, and nothing divides out. So nothing divides out, because remember, we can only divide out exact factors, so this is actually our answer. But now we've got to restrict our x values. So the bottom cannot equal 0. So set it equal to 0 and figure out when it does equal 0. So we're solving for c. Subtract 7. So we have 2c squared is equal to negative 7, divide by 2. So c squared is equal to negative 7 halves, square root it. So c is equal to plus and minus I. You pull out an I out of the negative square root. And then on top we have the square root of 7, on bottom the square root of 2. And I know I can't leave this as my answer, I got to rationalize my denominator. So c is equal to plus and minus, I multiply the bottom by the square root of 2, the top by the square root of 2. So I have I square roots of 14 all over 2. And so we know this is our answer as long as c does not equal plus or minus I square roots of 14 over 2. So this would actually be our whole answer here. This next one, it says simplify. So we always simplify if possible. The first thing I look for always is what's in common. In both terms, we have a 3x. So I factor out 3x. Left is x minus 3. So that's what's on top, and on bottom I have an x minus 3. Before you divide anything out, you've got to restrict your domain. So when will our bottom equal 0? So set it equal to 0 and solve. So I add 3. And it's only where there's a variable, correct? That's the only place that we have a problem. So x equals 3. If x is equal to 3, our bottom's equal to 0. So now we have restricted our domain, so now we can go ahead and divide out exact factors. We have a 3x on top, nothing on bottom. X minus 3 over x minus 3, they divide out and become a 1. So we have 3x times 1 over 1, which is just 3x. So our answer is 3x as long as x does not equal 3, or else our function's undefined. That's our final answer. Next one, 6z plus 12, and divided by 2z plus 7z plus 6. Factor the top, left is z plus 2, factor the bottom, and I do what multiplies to be, since it's quadratic, I'm doing what multiplies to be 12, adds up to be 7, 4 times 3, 4 plus 3. I've got a long factor, so 2z squared plus 4z plus 3z. So I'm dropping and breaking. So then I have plus 6. So then I group the first two terms, second two terms. In this group, there's a 2z in common. Left is z plus 2. Factor out a positive 3. Left is z plus 2. Factor out our safe haven, z plus 2. And left is 2z plus 3. So that's what our bottom factor to be was z plus 2 times by 2z plus 3. And make sure you restrict your domain before you divide anything out. So where are there potential problems? Right there, there's a variable, so z plus 3 is equal to 0. And then right there, there's a variable, so 2z plus 3 is equal to 0. And then solve for z in each case. You get z is equal to negative 3, and z is equal to negative 3 halves. You should be able to do the algebra quickly. So now that we've restricted our domain, we can divide out exact factors. We have a 6 on top, nothing that can divide with it on bottom. We have z plus 2 on top, it divides out with, oh, yeah, there's not anything, well, let's see here. Oh, I wrote z plus 3, but it was, this was z plus 2. Right? Z plus 2. I don't know why I wrote z plus 3. So we have z plus 2 on top, z plus 2 on bottom. They divide out and become 1. Left on top is 6 times 1, which is 6. On bottom we have 1 times 2z plus 3. And we can't divide anything out because remember 2z plus 3 is connected. So there's our answer as long as z does not equal negative 3 or negative 3 halves. And z does not equal negative 3 halves. So this would be considered our final answer. Okay, and this next one, 45, a little bit trickier. First things first, write things in standard form. On top I should have negative w plus 4. Rewrite that in a pretty, this is already in standard form. And then we'll factor each piece. The top does indeed factor because we have a negative in front. So we pull out negative 1, left is w minus 4. Only pull out a negative, we'd only factor that negative out if the negative's in front. And then on bottom, we factor this. What multiplies, since it's quadratic, what multiplies to be 16 and adds up to be negative 8. 4 times 4. No, let's see. And yeah, and they both be negative, which makes sense because negative 4 plus negative 4 does equal negative 8. Because our A values want a quick factors, so this quick factors to be W minus 4 times W minus 4. So I'm going to write that W minus 4 times W minus 4. Before you divide anything out, we restrict our bottom. So W minus 4 cannot equal 0, and W minus 4 equals 0. So I get W is equal to 4, and W is equal to 4. Okay, so now that we have restricted our domain, we can now divide exact factors out. We have a negative 1 on top, nothing on bottom. W minus 4 divided by W minus 4. And so on top, we have a negative 1 left, times 1, which is negative 1. On bottom, we have 1 times negative W minus 4, so we have a W minus 4. There's our answer, as long as W does not equal 4. Because those were our restricted values, so our function's undefined. All right, so number 46, hopefully you can factor this. I'm going to just factor it for you. I'm just going to write out the factors. You really should know how to factor, so I'm not going to take the time to do that. If you factor this correctly, you'll get 7z plus 2. So if you need to push pause on the video and factor this, I do that. The top factors to be 7z plus 2 and z plus 3. The bottom factors to be z minus 1 times z plus 3. Before you divide anything out, you've got to restrict your bottom. So you have z minus 1 cannot equal 0, and z plus 3 cannot equal 0. So z cannot equal 1, and z cannot equal negative 3. So now that you've restricted your bottom, your domain, you can divide out exact factors. So left on top is 7z plus 2. On bottom, we get z minus 1. And that's our answer as long as z does not equal 1 or negative 3. 1 or negative 3. Once again, push pause on the video. Make sure you can factor each of those by yourself. Okay, we're multiplying these two things. So when you're multiplying, you just factor everything. So we have 3x squared, and because x3 and x squared are just being multiplied together, nothing added to it, I can rewrite it as 3 times x times x. But we could not do that right here because x squared is connected to all this stuff. So don't make that error. Look at the difference. Nothing's connected to x squared, so you can rewrite it as x times x. If something's connected to it, though, by an addition sign or subtraction sign, you can't do that. So we have 3x squared, which is 3x times x, then we have x plus 2. And then we factor this, and it's quadratic, and it's quick factoring, so that factors to be, hopefully you can do that at this point, x plus 2 times x plus 1, and then it's all over x. And now we can just divide out exact factors. We have a 3 on top, not a 3 on bottom. We have an x on top and x on bottom. Those divide out. X on top, not an x on bottom. Do not try to divide it to this x plus 2. X is connected to plus 2. Now we have an x plus 2 on top and x plus 2 on bottom, so those do divide out because they're exact factors. So x plus 1 on top, not on bottom. So left on top was a 3 and an x plus 1. And on bottom we just had 1s. So our final answer is 3x times x plus 1. Next one, so 49. We're multiplying these two things. Factor each piece. So if you factor this, which you should be able to correctly, make sure you push pause on the video and don't just take my word for it. You have to be able to factor yourself. So it factors to be t minus 4 times t plus 3. And then this is t plus 1. And then times by t plus 1. Over t plus 3. And now we can divide out exact factors only. We have a t minus 4 on top, not on bottom. T plus 3 3's divide out. T plus 1, t plus 1's divide out. These all became 1s. So left was t minus 4 times 1 all over 1, which is just simply t minus 4. Anything times or divided by 1 is just itself. We're getting there. Number 50, we have x minus 1 over 6x plus 3 and times by this. Don't let it scare you. There's always a 1 underneath there, so this is just a fraction multiplied by a fraction. We always factor each piece. Pull out a 6, left is x plus 2. Factoring this piece, it is quadratic, and I do what multiplies to be a times c and adds up to be b. It's long factoring, so you really need to practice factoring this by yourself. If you do factor this, you get 2x plus 1. Now make sure you really practice it. If you just take my word for it, you haven't practiced factoring. And now you can divide out exact factors. X minus 1 on top, not on bottom. We have 2x plus 1 on top, not on bottom. This is the problem. I was like sitting here looking at this. Why I got one way too fast. This piece, we can pull out a 3. Left is 2x plus 1. There we go. Okay, so I didn't factor this piece correctly in the beginning, but now I've fixed it. Okay, so now I'll divide out exact factors. On top, on bottom, so they can divide out. And so we have an x minus 1 left on top, an x plus 4 left on top, and on bottom we have just a 3 times 1, which is 3. So this is our final answer. Okay, we're dividing these two things. Dividing fractions is easy as pie. You flip the second fraction and multiply. So we're going to flip the second one. So this 6g plus 2 is on top, and on bottom we have g squared plus 2g. So we flip the second and multiply. I'm going to erase this just to give me some room. Make sure you flip the second and multiply. So now we know how to multiply. Factor each piece. Divide out exact factors. So we have g plus 2 over 3g minus 1. And then we can factor 2 out. So we have 2, and then left is 3g plus 1. And then on bottom, we factor out a g. Left is g plus 2. Factor out, divide out only exact factors. We have a g plus 2, a g plus 2. We have a g plus 1, and a 3g plus 1, and a 3g minus 1 on bottom. They cannot divide out. They're not exact factors. So on top, we have a 2 and a 3g plus 1 left. And on bottom, we have a g and a 3g minus 1 left. Nothing else divided out. So that's our answer. Dividing fractions is easy as pie. Flip the second and multiply. So we're going to have 2c squared minus 5c minus 3 divided by 3c squared plus 12c. Now, I flipped the second and multiplied, and now we factor each piece. So make sure you factor correctly. I'm going to just give you the factors because I'm expecting you to push pause and factor yourself. So we have c plus 4 over c plus 2 times c plus 3, and we're times by, I expect you to factor yourself, c plus 3 times 2c minus 1, and then over 3c, so left is c plus 4. Divide out exact factors, but only if it's on top and bottom. So we have a c plus 4 on top and on bottom. We have a c plus 3 on top and bottom. We have 2c minus 1 left on top and c plus 2 on bottom. 2c minus 1 and c plus 2 on bottom. We're almost done. Flip the second and multiply. So x plus 6. So the top, so now I flipped the second and multiplied, right? And so we factor each piece. We have an x, left is x plus 6. We have an x plus 6 on bottom, times x over x plus 6. We have an x plus 6 on top, and on bottom it divides out, and that's it. You can't divide out. A lot of students start to divide things out like this, but they're both on top. It has to be on top and bottom. So on top we have an x squared left and x plus 6. Okay, this is a big, huge one. Dividing fractions is the easiest pie. Flip the second and multiply. So I'm going to flip this one. Flip this one. So on top, I'm going to have a 49t cubed. And on bottom, we have 6t squared minus t minus 15. So this is no longer there. I flip it, and now I'm going to multiply. So you factor each piece. So I'm going to factor this piece right here. So in common is a 7t. Left is t minus 4. I'm going to factor this piece, And I expect you to push pause and do it yourself the long way because it does take a long time to long factor. So we have, and if you can't quick factor, then you probably won't, if you can't long factor, you're not going to do well on the test. If you factor this correctly, you better get this. And then we're timesing by 49, and then there's 1, 2, 3 t's because of t cubed, right? And it's not being added to anything, so I can do that. And then I'm going to factor this, and you have to long factor, and if you do, you're going to get 3t minus 5 times 2t plus 3. So 2t plus 3. Now, only divide out things that are on top with what's on bottom. We have t minus 4, t minus 4. Those divide out. We have a 7 on top. Anything on bottom? No. A t on top. Any t's on bottom? No. 49 on top. Nothing on bottom? No. And then our t's on top don't divide with anything on bottom. So you're going to multiply those two things together. So you have 49 times 7. 49 times 7 is 343. So we have a 343 t to the 4th on top. And on bottom, 1, 2, 3, 4 t's on top, right? And then on bottom we have 2t plus 3, 2t plus 3. So I'm going to write it like this just for fun. 2t plus 3 squared. And then we have 3t minus 5. And this would be our simplified answer. A lot of students get in the habit of saying, oh, those two divide out, but they don't. They're not, one's not on top, one's not on bottom. So don't make that mistake. Okay, when adding fractions, you have to get a common denominator. So this is y to the 4th, and we have 3y squared. Nothing's being added, so technically we have 3 and 1, 2, 3, 4 y's plus 2, and we have a 3 and then 1, 2 y's. So common denominator. This has 4 y's, and it needs a 3. So I'm going to multiply the bottom by 3 and the top by 3. So now on top I have 9, and on bottom I have 3y to the 4th. Now with this one, it has a 3 and 2 y's. We need 2 more y's to make it 3y to the 4th. And so I'm going to multiply by a y squared to top and bottom. So I have plus 2y squared over 3y to the 4th. Now check, make sure your bottoms are the same. Now because we have a common denominator, we can go ahead and combine that into one fraction. So we have 2y squared plus 9, and it's all over 3y to the 4th. So the hardest part is getting a common denominator. So let's do this one, common denominator. You have to multiply by, common denominators only come from multiplication. So we have an m plus 2. We're going to multiply by n minus 7. There's no way of magically adding some things to get these things the same. It all comes with multiplication. So I'm going to multiply by m minus 7 over n minus 7. I'm going to multiply by n plus 2 over n plus 2. Distributing it through correctly. 9 times n is 9m. 9 times negative 7 is negative 63. And that's all over n minus 7 times n plus 2. Then we are going to multiply that through. So we have plus 8m plus 16. And then it's all over 7, n minus 7 times n plus 2. Now look at your denominators. Are they the same? Yes. So we can combine this into one thing, and we're going to combine like terms. 8m's plus 9m's is 17m's. We're adding them together, right? It was addition. We have to be more careful with subtraction. And then negative 63 plus 16 is negative 47. And that's now all over the common denominator of n minus 7 times n plus 2. So this would be our final answer. All right, common denominator, this one already has one. Look it, they're the exact same. So you'll just combine like terms here. So we have h squared plus 2h all over 2h squared plus minus 7. Oh, this was plus 1. Sorry, this was plus 1. So we actually had h squared plus h plus 1 all over 2h squared minus 7. This is actually the correct answer. Okay, common denominator. to be able to subtract or add fractions, you have to have a common denominator. You can't just magically add 2. A lot of students, I don't know, you think you can do that, but you can't. It's multiplication. So I'm going to multiply by a plus 5. If you do that to the bottom, you'll do that to the top. And you'll multiply by a plus 3. Top and bottom. Distribute that through. That's a squared and then plus 5a. And that's all over a plus 5 times a plus 3. Leave them factored. And then we will distribute negative 4 through to both things. Negative 4 times a. And if we do this, then we've taken care of the negative. So we have negative 4 a's. But carefully, you've got to distribute the negative 4 through to the negative 3, which is negative 12. So we have that all over a plus 5 times a plus 3. If you distribute the negative through with your whatever that is, then you've taken care of the negatives and you can simply add like terms on top. So we have an a squared on top, no other a squared, 5a's minus 4a's is plus 1a's, minus 12 all over a plus 5 over a plus 3. Now we would probably want to make sure that this doesn't simplify. So I would do, okay, this is quadratic. What multiplies to be negative 12 and adds up to be 1. 3 times 4, negative 3. And the quick factors, because our a value is 1. So the top factors to be a minus 3 times a plus 4. And so on top we have a minus 3, we have a plus 4, and on bottom we have a plus 3, we have a plus 5. So nothing divides out, so that would be our final answer. The reason I factored that one and made sure is just to make sure nothing simplified. Okay, common denominator. This is technically a 1. So our common denominator is 2t minus 3. If you multiply that by the bottom, you multiply that by the top. So we have a t on top and 2t minus 3. And then I'm going to distribute negative 11 through, so negative 22 t's. Negative 11 times negative 3, you've got to distribute the negative through. That's positive 33. And then it's over 2t minus 3. Do you have a common denominator? Yes. So we can combine it into 1, combine like terms. 1t minus 2t's is negative 21t's. Plus 33. And now we can have it all over the common denominator of 2t minus 3. Okay, with this one, there's no magic way of doing this. Like, you've got to just, I mean, there's really no magic way of doing this. Like, you've got to just multiply by t squared. And if you do that to the bottom, you've got to do that to the top. If you do that, and then this has a t squared, it needs a t plus 1. If you do that to the bottom, you've got to do it to the top. So 5t plus 5 over t plus 1 times t squared. Distribute negative 4 times t squared is negative 4t squared. And then that's all over t squared and then t plus 1. Check your denominator. Is it the same? Yes, so we can rewrite it in 1, combining all like terms. I'm going to write it in standard form, negative 4t squared plus 5t plus 5. And then that's all over t squared and t plus 1. That's the end of the review.